In this example, we're going to use the graph of a quadratic function to determine a possible formula in vertex form. So to do this, we're going to need to find the vertex and also one more point on the graph which will help us determine the leading coefficient a. Okay, so just to recall, the form that we're looking for in vertex form is f of x equal to a times x minus h quantity squared plus k, right, where hk is the vertex. In this first graph, the first thing I want to do is identify the vertex. So I'm going to put a little dot here, and what is that point? 3, negative 8? Okay, so if our vertex is 3, negative 8, what we know so far about the function, and I'm just going to use x's and y's here, y is equal to a times x minus 3 quantity squared minus 8, right? So when we have the x minus h is 3 in our case, right? And k is negative 8. So I'm just plugging that into the general form for the vertex form. Okay, so I know that much about the function, but I still need the value of a. That's still a parameter that I need to find. Okay, so I'm going to find, in order to find a, I need to find another nice point on this graph. And by nice point, I mean a point where the x and the y value are integer values, or at very least that we can tell that by the graph. So I'm noticing, let's say 2, negative 5. And by the way, make sure that your nice points aren't x-intercepts, because if you use an x-intercept, and you plug it in for x, you'll end up with 0 times a. It's not helpful. So some other point other than an x-intercept. And I picked a point here. What is the point? 2, negative 5. Yeah. Okay. So I'm going to use that point in this formula. So I'm going to have a y value of negative 5 and an x value of 2. And now I have a little equation that's just in terms of a, and I can find a. All right, so let's do the arithmetic here and solve for this for a. So 2 minus 3 is negative 1, but I'm squaring it. So I end up with just a, right, minus 8. And I'm going to add 8 to both sides. Okay, so 8 minus 5 is 3. So 3 is equal to a. Right? So that means our formula would be f of x equal to 3 times the quantity x minus 3 quantity squared minus 8. Okay, so hopefully that makes sense. The hardest part is finding that leading coefficient, but as long as you have another point that you can use to stick in for x and y, you have an equation that you can solve for a. So the other thing I notice about the a value is that it's positive, right? And this graph opens up, right? And we learned that if a is greater than 0, then the parabola will open up. Whereas over here with this second example, I have a feeling that a is going to be negative when we find a, okay? So going through this same process, I want to find the vertex, identify what that is. So it's up here at negative 2, 6. Okay, so we have a vertex of negative 2, 6. So that means we minimally know now that y is equal to a times x plus 2, right? Because we're subtracting a negative, so we're adding there. X plus 2 quantity squared plus 6, right? We've shifted it up 6 units. Okay, so now find another nice, like I said, nice point that you can use, something with integer values. And I said you can't use an x-intercept, but you can totally use a y-intercept, and that's usually the nicest one. If you have the y-intercept, it makes the arithmetic a lot easier. So 0, 4 is the y-intercept there. And that means that if our y value is 4 and our x value is 0, we can solve for a, right? We have 4 equal to a times 0 plus 2 quantity squared plus 6. And 0 plus 2 is 2, right? And 2 squared is 4. So we have 4 equal to 4a plus 6. And then I want to subtract 6 from both sides, right? 4 minus 6 equal to 4a plus 6 minus 6. So negative 2 is equal to 4a. And we're going to divide both sides by 4. So negative 1/2 is equal to a when I reduce that. And what did we say? We said that a was going to be negative, right? Since it was a parabola that opened down. What will the function be then? We'll have f of x equal to negative 1/2 times x plus 2 quantity squared plus 6.